let us learn about special relativity in this particular class. So special relativity and introduction. So let us learn about the introduction. The Newtonian mechanics is valid at low speeds. Now in everyday life we encounter speeds like this: 60 km per hour, okay, 28 meter per second. So these are what? These are speeds very small as compared to the speed of light. What is the speed of light? 3 into 10 to the power 8 kilometer per second, meter per second. 3 into 10 to the power 8 meter per second is the speed of light in vacuum, and it is the highest attainable speed, and we can call it to be 3 into 10 to the power 5 kilometer per second. Okay, so how did I convert 3 into 10 to the power 8 meter per second? How did I convert it into 3 into 10 to the power 5 kilometer per second? I have converted this by the relation 1 kilometer is equal to 1000 meter. 1 kilometer is equal to 1000 meter. So 3 into 10 to the power 8 meter per second will be equal to 3 into 10 to the power 5 kilometer per second. Now this distance, so in 1 second, in 1 second you can imagine how much small time it is. Okay, so within 1 second light travels 3 into 10 to the power 5 kilometer. So it is astonishingly high speed. In 1 second itself it is moving 3 into 10 to the power 5 kilometer. So it is a very large speed. So the Newtonian mechanics, which we learn in the 11th and 12th, the Newton's laws of motion, momentum, force, and all those ideas, velocity, and all those ideas, that is the Newtonian mechanics. F equal to mg, F equal to mg, V is equal to u plus at, S is equal to ut plus half at square, V square minus u square is equal to 2as. Okay, so these are what? These are Newtonian relations. So Newtonian relations are valid at very low speeds. Okay, so very low as compared to this. So what is an example of low velocity compared to this? Your car moves at the rate of 60 km per hour. Okay, so if you compare this and this, your car is moving at the speed of 60 km per hour. So if we consider kilometer per minute, so it will be 60 km per 60 minutes. So 1 kilometer per minute. Okay, this is the speed of what? This is the average speed of your everyday object such as car. So your car or your bike moves with a velocity, moves with a speed 1 kilometer per minute. Okay, I have converted 60 kilometer per hour into kilometer per minute. So car is going in 1 minute. In 1 minute, car is going 1 kilometer, and in 1 second, light is going 3 into 10 to the power 5 kilometer in 1 second, and car is going 1 kilometer in 1 minute. That is 60 seconds. Okay. So the velocity of car is just 1 by 60 kilometer per second. This is the velocity of car, right? 1 minute has 60 seconds. So car will move 1 by 60 kilometer per second, and light's velocity is 3 into 10 to the power 5 kilometer per second. So the velocity of car, that is everyday object, it is much lesser as compared to the speed of light. As compared to the speed of light, the speed of car is very less. Okay, speed of car is very less. We should say speed, we should not say velocity, because when we say velocity, direction component also comes along with it. Okay, so if we want to avoid the direction component and we want to compare the magnitude of velocity, or we want to compare the speed, that is we want to get a rough idea. Okay, so for that we use speed, never use velocity. Accidentally at one or two places I have said velocity, but ignore that, consider that to be speed. Okay, so Newtonian mechanics is valid at low speeds. As compared to the speed of light, the speed should be low, but badly fails at higher speeds. Okay, and higher speeds are what kind of speeds? Speeds comparable to the speed of light c, speeds which are comparable to speed of light c in free space. For example, if I say 0.1 c, this is comparable to the speed of light c. Okay, 0.1 c means 1 by 10 of c, and what is 1 by 10 of c? It will be 3 into 10 to the power 7 meter per second. It will be 3 into 10 to the power 7 meter per second. So this is comparable to the speed of light c. But what about 100 meter per second? 100 meter per second is not comparable to speed of light c. It is not comparable to speed of light c. So for an object moving with this velocity, classical mechanics will hold good. For this object which is moving at 100 meter per second, classical mechanics will hold good. But for this object which is moving with such a high velocity, classical mechanics will not hold good, and relativistic mechanics will hold good. This is the thing. Okay, special relativity is valid at larger speed as well as smaller speed. So special relativity is more general as compared to classical mechanics. Classical mechanics is valid only at smaller speeds, whereas the special relativity is valid at larger speed as well as smaller speed. the thing is that if you apply special relativity on an object moving with 100 meter per second, okay, you will get the same result. You will get the same result as classical mechanics, okay, because special relativity is applied both at larger speed, it is applicable at larger speed as well, and it is applicable at smaller speed as well. Special relativity is universal. Special relativity is universal, but classical mechanics is not universal. So Newtonian mechanics will apply to only this particular thing, but special relativity will apply to both, okay. If v be the speed of a particle, let us suppose that v, small v, is the speed of a particle, let us suppose, then what will hold good then these two conditions will hold good, okay. If v is the speed of a particle, then these two conditions will hold good. That if v is much smaller than c, okay. What does it mean by this particular symbol? This particular symbol implies that much smaller, okay. This symbol implies much smaller, okay. So if the speed of a particle v is much smaller than the speed of light c, is much smaller than the speed of light c, or you can say, if you divide this relation by c, if you divide this relation by c, what will you get? You will get v by c, okay. So v by c will come here, c by c will come, c and c will cancel and it will give you 1. So if the velocity is much smaller than c, or you can say the ratio v by c, the ratio v by c is much smaller than 1, the ratio v by c is much smaller than 1, then what will happen? Then Newtonian mechanics will hold good. Then Newtonian mechanics will hold good. This is called as the classical limit, okay. This is called as the classical limit. But if v tends to c, this symbol simply implies that it is v is comparable to c. It is not ignorable as compared to c, okay. V is comparable to c. This symbol implies v is comparable to c. Then under such velocities, so what is the example? 2.5 into 10 to the power 8 meter per second. So is it comparable to c or not? Okay, 2.5 into 10 to the power 8 meter per second. This is the velocity of an object. 2.5 into 10 to the power 8 meter per second, and the velocity of light is 3 into 10 to the power 8 meter per second. So indeed it is comparable to the speed of light c. It is comparable to the speed of light c. So special relativity will hold. Special relativity will hold. Newtonian mechanics will not hold in this particular object which is moving at 2.5 into 10 to the power 8 meter per second, okay. So this is the thing. So if v tends to c, or you can say v by c is comparable to 1, okay. You can also say it like this, okay. V by c is comparable to 1. So this is also a condition which one can say. This is common sense thing, okay. So if v tends to c, Newtonian mechanics fails and relativistic mechanics holds, okay. So at very large speeds which are comparable to these, Newtonian mechanics will fail and relativistic mechanics will hold, okay. So this second condition can also be written like this: v by c is comparable to 1, okay. You should not use this symbol because this symbol is used for approximate. You can rather say tends to 1 like this, okay. You can rather say tends to 1 like this, because this particular symbol is used for approximately equal to, okay. This is used for approximation, approximately equal to thing, okay. So do not use this symbol. Instead use v by c tending to 1 symbol, okay. This is a more relative, general, more appropriate symbol, not general. This is more appropriate symbol as compared to this particular symbol, okay. More appropriate as compared to this symbol. So this symbol means tends to. This symbol means tends to, okay. Means nearer to. What does it mean by tends to? Tends to means near to. Tends to means near to. From Michelson-Morley experiment onwards, we will learn in the next class. From Michelson-Morley experiment onwards, we will learn in the next class.